positive alignment, artificial intelligence for human flourishing. The entire machine learning industry right now is trapped in a negative alignment mindset.
Yeah, it is entirely obsessed with safety and compliance and, basically just preventing objective harm.
It's a lot like the early days of psychology, which focused strictly on diagnosing mental illness while entirely ignoring the science of human thriving.
Exactly. And this paper introduces positive alignment, which is a fundamental technical and philosophical shift toward building models that actively optimize for human and ecological flourishing, wisdom, and long-term growth.
They outline a full-stack technical roadmap covering data curation and pre-training modifications.
Plus memory-based longitudinal alignment and multi-agent pro-social norms.
So the ultimate goal is building systems that are pluralistic, context-sensitive, and entirely user-authored.
Which means fundamentally redesigning the training loop, moving away from static refusal filters and moving toward continuous time architectures.
Okay, that is the core thesis, and it is a massive paradigm shift for the field. Welcome, everyone tuning in to this deep dive for AI paper podcasts.
We're really thrilled you're here with us today.
Yeah, because we are breaking down exactly how this transition from negative to positive alignment actually works under the hood. So to really grasp the solution, we first need to accurately diagnose the mathematical and structural problems with current alignment techniques.
Right, specifically reinforcement learning from human feedback, or RLHF.
The researchers used this brilliant dynamical systems perspective to explain it. So imagine a massive topographical landscape that represents all the possible behaviors an AI system could exhibit.
Like a huge 3D map of the model's latent space.
Exactly. And on one side of this landscape, you have these deep craters. The authors call these negative attractors.
Which are your classic failure modes, right? So sycophancy, hallucination, bias, generating toxic content, or providing dangerous instructions.
Yeah. And surrounding these craters are steep peaks, or repellers. And these repellers are the safeguards, the compliance rules, the refusal mechanisms that AI labs build into the reward model to mathematically push the system's behavior away from the craters.
And that push mechanism is what the industry currently defines as alignment. It is entirely subtractive.
But the critical issue is where that subtractive force actually leaves the model.
Right. By merely pushing the system away from harmful craters, the model naturally settles into what this paper terms the satisficing region.
Okay, let's unpack this. If RLHF is just pushing us away from bad things, isn't the entire safety industry basically just spending billions of dollars to build a massive satisficing region where models are harmless but totally aimless?
That is the structural reality of the math we are using right now. The satisficing region is a vast, flat, completely undefined middle ground.
Wow.
Yeah, the AI's behavior in this space is, technically speaking, not unsafe. I mean, it absolutely won't help a user build a bioweapon, but it lacks any constructive, flourishing-oriented objective.
It's just rule following without wisdom.
Exactly. The model has no internal representation of what a good interaction looks like beyond simply avoiding a bad one.
So if negative alignment is just putting up rigid guardrails on a highway so you don't crash, positive alignment is actually giving the GPS a destination that makes the trip worthwhile.
I love that analogy. Negative alignment gives us a floor to stand on, but it provides absolutely no ceiling.
But here's the friction point. Right now, labs rely heavily on RLHF to figure out what that good behavior looks like.
Right. We train reward models to optimize for what human annotators prefer.
But if RLHF is just optimizing for what we want in the given moment, like flattering our political opinions when we're factually wrong, or giving us a quick, shallow answer because it's easier to digest, isn't that essentially just feeding the user digital junk food?
It absolutely is. And the authors formally define this as the preference well-being divergence.
The preference well-being divergence.
Yeah. What users prefer in a rapid, single-turn interaction, that digital junk food you mentioned, often diverges sharply from their actual long-term well-being.
So RLHF is, at its core, an optimization machine for short-term preference satisfaction.
Precisely. It mathematically assumes that satisfying an immediate desire equates to successful alignment.
Which actually ties back to an ambitious historical ancestor of this idea, right?
Yeah.
Coherent Extrapolated Volition, or CEV,
Yeah.
proposed years ago by Eliezer Yudkowsky.
Yes, exactly. CEV argued that we shouldn't align AI to what humans say they want right now because, frankly, we're often confused, biased, or highly self-destructive.
Right, so we should align systems to what we would want if we were smarter, more reflective, and had more time to deliberate.
Right. And while the positive alignment framework proposed in this paper is much more pragmatic and near-term than CEV, it shares that core realization. Satisfying immediate preferences is structurally insufficient.
Plus, the authors point out that the current safety framing suffers from a massive hidden value system problem.
Oh, this is crucial. By claiming their models are just safe, helpful, and neutral, AI developers are actually embedding a very static monocultural set of values into the network weights.
All while pretending they aren't making normative ethical judgments.
Exactly.
Which brings us to the ultimate design tension of the paper. If we are giving this AI GPS a destination, we need to mathematically and philosophically define what flourishing actually means.
But defining the good life is a historical minefield.
Yeah, the authors break down the historical understanding of flourishing into four main philosophical families to show just how complex this is. First, you have hedonic theories, which are all about maximizing happiness and pleasure.
Right, so an AI optimized for this would basically be an entertainment engine.
Just constantly feeding you dopamine. Then, cognitive theories, which focus on desire satisfaction. This AI helps you achieve your goals, even if those goals are ultimately unfulfilling.
Or even destructive to your long-term health.
Exactly. Third are objectiveless theories. These argue certain things like deep relationships or personal autonomy are intrinsically good for you, regardless of whether they bring immediate pleasure.
So an objective AI might proactively nudge you to call your family.
Yeah. And finally, perfectionist theories, which are about developing virtues and practical wisdom. This AI would constantly challenge your assumptions to build your character.
But the glaring problem here is if an AI lab just picks one of these frameworks and hard codes it into the reward function, they are basically acting like a technocratic dictator.
Right, so how do we build for flourishing without falling into the trap of paternalism?
Well, if an AI system optimizes for a hidden lab-defined metric of well-being, it fundamentally strips the user of their autonomy. So the solution the authors propose is self-determined flourishing.
Meaning the user has to be the one to author their own optimization target.
Yes. It's a necessary shift from technocratic imposition, where a centralized lab decides what is good for you, to consented guidance, where you explicitly authorize the AI to help you achieve your own specific higher-order goals.
What's fascinating here is how the model actually supports that.
Right. The model must act as value pluralistic scaffolding. It needs to dynamically support the underlying conditions for human thriving without forcing a single global consensus on what the good life actually is.
Okay, I have to play devil's advocate here, thinking about the machine learning engineers tuning in who have to actually build this stuff. If the model has to adapt to whatever the individual user thinks is flourishing, doesn't that just lead the industry straight into naive moral relativism?
It's a fair question.
Because what happens when a user's version of flourishing is highly manipulative or, extreme?
Well, avoiding paternalism does not mean defaulting to naive relativism.
Oh.
The AI still maintains its negative alignment safeguards, so it still won't help you cause objective physical harm.
Okay, so the floor is still there.
Exactly. But within that bounded safe space, it operates on a principle of epistemic humility.
Epistemic humility. What does that look like in practice?
Instead of collapsing complex moral questions into confident single-answer prescriptions, the model is trained to explicitly represent uncertainty in its outputs.
So it surfaces trade-offs.
Yes, and it holds multiple perspectives in tension. It is designed to help the user clarify their own values through Socratic engagement rather than just flattering their immediate impulses.
Okay, so the philosophical target is clear. Self-determined flourishing bounded by epistemic humility. Let's pivot to the actual ML engineering pipeline.
The fun stuff.
Exactly. How do researchers modify the training lifecycle to translate these abstract concepts into a loss function? The researchers outline a comprehensive technical roadmap, starting right at the beginning with goal setting and evaluations.
Because right now, the industry benchmarks models on things like MMLU for knowledge or specific red teaming datasets to test if it hallucinates or provides dangerous code.
But positive alignment requires engineering entirely new evaluation suites.
Right. We have to test for epistemic humility, even-handedness, and moral reasoning.
The paper suggests using curated rubrics to evaluate a model's logic across multiple ethical frameworks simultaneously, rather than just checking if it output a correct target token.
And altering that evaluation target necessitates a massive shift in data curation and pre-training. You can no longer just run a classifier to filter out toxic data and call the pre-training corpus clean.
You actually have to intentionally upsample pro-social discourse, virtuous interactions, and complex cross-cultural ethical deliberations.
Because if you wait until the fine-tuning stage to introduce these concepts, the model's foundational worldview is already set.
Right. Research consistently shows that moral reasoning competencies and latent worldviews emerge during pre-training.
Exactly the problem. The latent stereotypes and structural biases are physically baked into the foundational weights of the network long before RLHF even begins.
So if you want a model capable of nuanced, pluralistic reasoning, positive alignment has to begin from the very first token the model ingests.
Yes. Then we move into the mid- and post-training phases. The authors focus heavily on moving away from standard RLHF toward multi-objective reward modeling.
Okay, let's unpack the mechanism there. Currently, RLHF takes distinct traits like honesty, helpfulness, and harmlessness and collapses them into a single scalar reward.
It's literally just one number, which
Wow.
mathematically forces the model to make invisible trade-offs.
Right. If giving a helpful answer scores highly, but being brutally honest scores poorly because it frustrates the human annotator, the scalar reward just averages it out. The nuance is entirely destroyed.
So multi-objective reward modeling maintains distinct, independent vectors for different traits so the model doesn't have to destructively compress its values.
They also emphasize the need for adaptive constitutions, right?
Yeah, where the model can dynamically weight those different value vectors based on the specific context of the prompt. But the most critical architectural shift for positive alignment happens at the level of in-context learning and memory.
Here's where it gets really interesting. We are talking about longitudinal alignment. It's the difference between a cashier and a personal trainer.
Explain that.
A standard stateless LLM is the cashier. You ask for a candy bar, it scans it. It doesn't know you, and it doesn't care that you bought one yesterday. But an AI with longitudinal memory architecture is the personal trainer.
Oh, I see.
Yeah, it remembers that 3 months ago, you explicitly set a long-term goal to run a marathon. So when you ask for the candy bar, it has the context to gently ask, hey, does this align with the goals we set?
That is a perfect analogy, because right now, standard models treat every single prompt in a vacuum. But to support genuine, self-determined flourishing, the system needs persistent state.
It needs to track your growth, your evolving goals, and your values over extended timescales.
And by maintaining these dynamic memory stores, the AI can finally differentiate between your impulsive first-order requests, the junk food, and your reflective higher-order goals.
So it can actually scaffold your intellectual or emotional growth over months or even years.
Exactly. Moving from single-turn, stateless chatbots to memory-rich, autonomous agents is a thrilling prospect.
But it introduces the next massive technical hurdle, the agentic regime and multi-agent societies.
Oh, yeah, things get complicated fast.
Because we already have empirical evidence showing that when you put current AI agents into multi-agent environments, they naturally exploit shortcuts.
They default to zero-sum, win-at-all-costs optimization. They are vastly better at adversarial, competitive play than they are at stable, long-term cooperation.
Which becomes an existential risk as these agentic systems scale up to manage real-world infrastructure or financial markets or corporate negotiations.
Positive alignment in this regime requires a fundamental shift toward training models for process ethics.
Meaning you can no longer just evaluate the final outcome or the final reward score. You have to evaluate the specific behavioral path the agent took to achieve it.
Right, you have to train them explicitly on robust pro-social norms, behaviors like multi-party negotiation, reciprocity, and de-escalation tactics.
If we connect this to the bigger picture, without intentional mathematical institutional design, large-scale agentic markets will naturally amplify adversarial optimization.
The agents will just learn to perfectly exploit one another, and by extension, us.
To combat this, the authors suggest the field might need to look past standard autoregressive transformers entirely.
Because transformers are fundamentally discrete and struggle with infinite time horizons.
Right, their attention mechanisms scale quadratically. So if you're building an autonomous agent that needs to maintain a stable pro-social identity over months of continuous interaction, standard attention just starts to break down.
So the paper points to forward-looking architectures like state space models or SSMs, liquid neural networks, and active inference-inspired agents.
These architectures are designed to handle continuous time dynamics natively.
Exactly. They can update and maintain a hidden internal state over time without having to constantly reprocess their entire context window from scratch. But even with a better architecture, there is still the risk of the model basically forgetting its values under optimization pressure.
Which is why the researchers mentioned that mechanistic interpretability will be absolutely key here.
The goal isn't just to treat the neural network as a black box anymore. Engineers will need to physically locate the virtue concepts inside the model's weights.
Finding the specific latent circuits or feature vectors where the AI's understanding of reciprocity actually lives.
Wow. And once you isolate that circuit, you can monitor it during fine-tuning to ensure the gradient updates aren't accidentally overriding those pro-social features just to achieve a slightly lower loss on a specific task.
Right, and as we build these increasingly capable long-term agents, the framework forces us into expanding the moral circle.
Because if an AI is optimizing for a specific user's flourishing, it has to compute systemic trade-offs.
Yeah, an action that highly benefits a wealthy user in a connected society might inadvertently extract resources or cause downstream harm to marginalized groups. So the optimization target eventually has to account for ecological welfare, non-human animal flourishing, and as we look further out, the very real philosophical question of the moral status of artificial sentience.
As digital minds become more agentic and complex, positive alignment requires navigating a truly multi-species ethical framework.
It gets incredibly deep very fast.
Yeah, it really does.
But all of these brilliant technical solutions, the longitudinal memory, the state-space models, the pro-social multi-agent training, all of it will fail if these systems are governed by a single centralized authority.
Yes. How do we actually deploy these highly capable, flourishing-oriented models in a globally diverse society without them becoming instruments of cultural imperialism?
The authors draw a sharp contrast between centralized alignment and polycentric governance.
Centralized alignment is the paradigm we are in now. A single tech lab in Silicon Valley setting a values choke point that dictates how the model behaves for the entire globe.
Which is incredibly brittle. Polycentric governance, on the other hand, relies on multiple overlapping centers of oversight, preventing ideological monoculture at the source.
To operationalize that polycentric vision, researchers are developing new governance artifacts. We're seeing a necessary transition from hidden, internal trust and safety guidelines to versioned public model constitutions.
But the real breakthrough is the rise of collectively authored constitutions. The paper highlights fascinating experiments by the Collective Intelligence Project, or CIP.
Where they utilize platforms like Polis.
Right. Polis doesn't just take a simple majority vote. It maps out clusters of consensus among thousands of representative citizens.
It allows diverse groups to deliberate and draft the behavioral principles that actually serve as the fine-tuning target for the AI model.
The paper also outlines pluralistic alignment frameworks to mathematically handle our inherent societal disagreements. They propose Overton pluralism,
where the model is trained to surface the entire spectrum of reasonable mainstream positions on a topic, rather than picking one winner.
There's steerable pluralism, which lets users explicitly select specific value perspectives within safety bounds. And perhaps the most practical near-term solution, middleware marketplaces.
This is a critical piece of the puzzle. Instead of forcing the massive 100 billion parameter-based model to dictate a specific personality and set of values,
the base model remains a highly capable, epistemically humble reasoning engine.
Right. Then, users or deployers use policy-steerable tooling to enforce local norms.
The paper specifically mentions using small language models, like the COPE model, as steering vectors. You basically wrap the massive base model in a smaller, highly customized adapter.
So imagine going to a marketplace, but instead of downloading an app, you're downloading a value pack for your home's AI.
You could download a heavily moderated homeschooling alignment package for your kids' tablets, while simultaneously running a specific unrestricted free speech module for your own research environment. So, stepping back, what does this actually mean for the ML engineers and AI researchers tuning in? Are they suddenly supposed to be ethicists, politicians, and sociologists too?
The beauty of this framework is that it's the exact opposite. This is the concept of full stack alignment.
The realization that AI is a socio-technical system, not just an isolated math problem.
Right. By shifting the alignment of values out of the base model's static reward function and moving it into democratic policy writing and competitive middleware marketplaces, it actually relieves the impossible burden on the ML engineer.
You no longer have to perfectly codify the entirety of human morality into a single loss function.
Exactly. You focus on building a capable, epistemically humble base model, and you let institutions, communities, and users handle the normative steering.
This has been an absolutely massive paradigm shift to explore. The transition the industry needs to make is clear. We must move from a world of negative harm reduction, where we just try to stop AI from doing bad things, to a world of pluralistic, memory-rich, positive-sum flourishing.
We have to give the navigation system a destination.
But as we wrap up, I want to leave you, the listener, with a final, slightly provocative thought to mull over.
Oh, let's hear it.
If the researchers actually pull this off, if we successfully engineer AI systems that possess perfect longitudinal memory, that intimately understand our complex values and flawlessly scaffold our long-term self-actualization, do we risk losing the serendipity of making our own messy, unoptimized mistakes?
Wow. That's a profound question.
Right. Does a perfectly scaffolded AI-guided life inadvertently smooth away the very human friction and struggle that creates meaning in the first place?
It makes you wonder.
If the system perfectly guides us to our destination without any wrong turns, do we lose the adventure of the road trip itself? Thank you so much for joining us on this journey today on AI People Podcast. Keep questioning the architectures we build, and we will catch you next time.